Hello, good afternoon. Welcome to our workshop today. We are Penn State Game Design Development Club, and we are here just to teach you an introduction to game development and basically what you can expect when pretty much going to build a game with a general engine. We will be using Unity today, but before we begin, my name is Matan Botansky. I am the club president, and today presenting with me, I have my fellow club members, Johnathan, Tran, and David Reinoso, and we will be giving you a brief intro. So just so you know ahead of time, we will have a 25-minute presentation and then a short demonstration, and we will answer questions at the end. But for now, what will happen is we will have a PowerPoint. We will go through it. We will try and get it provided to you at the end so you can refer to it, because we will be throwing at you quite a bit of information. If you want, you can follow along on the Unity program, which we've recommended that you download. But if you don't, it's okay. As long as you just watch and get kind of an idea of how it works, it will be fine. So let's just jump right into it and begin. So firstly, we wanted to discuss what is a game engine. Now, a game engine is basically a software development environment that allows you to make games without starting from scratch and skipping all of the software engineering steps, and basically using built-in libraries to simplify your work, making you more efficient and basically allowing you to have a more of a hands-on approach, which you can use visually and basically manufacture the game the way you want. So there's two main ones that you may have heard of already, Unity and Unreal. Both of them have free options and are very similarly built. And they both have interfaces that allow you to build games without any actual scripting. So we, as a club, and in general, I would recommend to all beginners, start off with Unity. Firstly, it's a lot easier. You have the ability to make 2D and 3D games. It's very, very beginner friendly. It has amazing libraries and forums, and even the documentation for Unity itself, I think, is absolutely wonderful. It's probably one of the best looking documentations I've seen for anything I've used to do with programming. And it's just very easy to use a multitude of different files, models, whatever resources you want to use in your game. And you can make games for many, many, many platforms, anything from iOS to Mac to PC to whatever game consoles you might make for, although you might not do that as a beginner, but it's all right. So yeah, so we like to use Unity, and that's what the presentation will be discussing today. And yeah, let's keep going. So when you initially boot up Unity, you're going to create a new scene. A new scene would look something like this. We have several sections here. So firstly, we have the hierarchy section, which is any object that you have live. When you create a new scene, and this is a 2D, it's slightly different between 2D and 3D. In 2D, it's going to look like this. You're only going to have a main camera. In 3D, it's going to be the same, except you're going to have an additional directional light that appears by default. Here you have the scene view, which is all the objects that are currently on your scene. You also have the game view, where if you click this, I can't actually because this is a screenshot, but you will actually be able to see what the camera sees. Here you have an inspector, which if you click on an object from the hierarchy, you will be able to see all its properties. And you have your project folder right here, which contains all your files and assets that you use during your game. So first, we're going to talk about the hierarchy itself, and I think David's going to present that.
Yes, so as Matan mentioned previously, the object hierarchy is a window within your interface that shows all the objects and their children that are in a scene. So think of the scene as either a 2D or a 3D world. In this case, this picture has a 2D world where we have the text that says shopping list, we have the background image, and we have 4 market booths. Each of these components, or each of these objects, are all going to be able to be found in the object hierarchy window. Now, in this window, you can define whether an object is a parent or a child of another object, just meaning that one depends on the other in terms of transformation or translation or rotation or scaling. And for the next topic on the agenda, we have components. Now, components are the basic properties of an object. If you think of an object as a folder, you could think of components as files within that folder that provide information about that object. You can view these components in the inspector window. Now, different objects use different components, such as a text object might use a text component, while an image object might have an image component that you can establish what image is going to be displayed. Now, Unity has many built-in components that are easy to use. These are predefined components that are really plug and play. As you can see on the right, we have a whole list of fields that you can enter in whatever values you desire. Now, components can also be controlled and edited by scripts. And scripts are actually custom components, but we'll get into that in the next slide.
So in terms of scripting, Unity has a very, very easy to use system. Firstly, it's important to mention that the primary language used in Unity is C#. It is the built-in language, and it is and it basically contains most of the Unity libraries. Unity also, usually when you install it, you also install the free version of Visual Studio. And they interact very well together. You can open and close files within Unity, and basically they mesh really well together with Visual Studio. So basically, every script that you create in Unity is a public class, meaning that they can act as these components for objects. Every script that is a public class that extends monobehavior, that I'll talk about in a minute, can be attached to an object and basically act as a component and give it some extra properties, and also manipulate the properties of other components attached to the object. We'll talk about those components in a bit, but for now, that's what scripts do. Now, I'd like to mention that Unity has many, many, many built-in functions and libraries that are very useful to use. They've been developed for years, and there's just so much of a variation of what you can do. It's also important to mention that most scripts in Unity extend monobehavior, which is just basically the superclass and the base class for all Unity scripts. And they include many different temporal functions, which, for example, when you make a new script, this is what shows up. We have a void start and a void update, where the void start is a function that is contained within monobehavior that allows Unity to run whatever you put during that first frame, whereas the void update occurs every single frame that the current object is existing, pretty much. So monobehavior also allows us to do more things involving our components. It just gives us more accessibility when using Unity.
Now, onto transforms. Transforms are also components much like scripts, but the transforms are components that contain basic information about an object, like the object's position within the 2D or 3D world, or the object's rotation within that world, as well as the object's local scale, as in how big it is or how small it is. Now, there's also a difference. There's a specification in Unity between the local scale and the lossy scale, in which the local scale is relative to the object itself in terms of an image, maybe how many pixels are in that image, as opposed to the lossy scale, which is relative to the scene and the parents of the object. For example, how many pixels of that image are in one unit of the world that the image is put in. Now, a more detailed version of transform can easily be scripted and is contained within Unity's libraries. So transforms are mostly manipulated within scripts to change the position, rotation, or scale of an object based on an action or event that might take place within the game as it is running.
The rigid body as well.
Right. Yes. So another component that is found in Unity is the rigid body component. This is a physics component of either 2D or 3D objects. This component will allow you to apply anything in terms of physics to an object within the world. So this will also deal with how an object might react based on colliding with another object, or how it might react if you have gravity within the world. Now, this rigid body component, you can, as you can see, change the mass, drag, angular drag, or if this object uses gravity, you can change all these properties of the object.
Next up, to go with the rigid body, something that's very frequently used together, they blend in quite well, is colliders and triggers. Basically, what colliders and triggers do is they provide you a way to detect collisions between two objects, which is something that happens very commonly within every game that we play. And basically what happens is you can have each object would have a collider, so a general shape in which, so that the computer knows where the object is, or a hitbox is what you may hear in terms for most games. And it would also have, and one of them would be a trigger that when a collision occurs, then an event happens. And now that event is what you decide it to be, of course. So I'll explain more about that in a minute, but colliders basically come in many, many different shapes and sizes that are invisible. For example, in the left-hand picture, you can see I have in one of my 3D projects, we have a ship. And above that ship, I've shifted the collider a little bit up. That's not actually where the collider is. Just so you can see the shape, we have a polygonal mesh collider that is a trigger and can basically know if when that ship is touching anything. And in this game, I don't have a picture of it, but when the ship hits ice, then it breaks the ice. So the ship would be a trigger and would have a function that will break the ice once the two objects collide. The simple implementation uses functions such as on collision enter and on trigger enter, where the latter is used more commonly to do many, many things. Next is the Sprite and Mesh renderer, which is the last component I think that we're going to talk about in detail here. And they just basically contribute to the physical appearance of an object. The mesh renderer is just, if you have a mesh renderer, you can see the object. If you don't have a mesh renderer, you can't see the object. In 3D, it basically contains the model, and in 2D, it contains the sprite. It can also include shaders and materials and all these different things that you can play with and make really anything in Unity. It's also very easy in Unity to import models from other programs and basically use them over and over again. In terms of assets, I believe Johnathan was going to explain this one.
All right, so assets are essentially any item that's used in your game, which is a very broad term, but it literally is that. Most of these are actually files that are added outside of Unity. Things like that would include 3D models, audio files, images for backgrounds or different items in the game, sprites, fonts, and animations. And just go over sprites real quick because I'm sure you've heard it a few times so far. Sprites, at least in a 2D case, it's a 2D bitmap used for 2D games. It's most commonly seen in 8-bit or 16-bit games. So the character model for Mario in 8-bit Mario is essentially a sprite. And other things are actually built in. Other assets, I mean, are also built in. Things like textures, animations, and cameras. In that picture you see there is actually a screenshot from our game that we've collaborated on, and it has all of our assets. It has our animations, our fonts, our materials, our resources, scenes, scripts, and sprites, and then our prefabs, which I will go into next. So prefabricated objects, which we just call prefabs, is a system that allows you to store components, including their properties, so all of their components as well. And we do this so we can essentially reuse the item multiple times. You can essentially think of it as a base template for a game object that you want to use later down the line. You'd probably do that for objects like enemies, NPCs, buildings, or items. A game may have multiple NPCs, but the base of it may all be the same prefab, just different textures. So in the picture we have there, the main prefab, the most notable one is the coin one. We use the coin prefab to generate that within our different levels. And so next is the UI canvas objects. So when creating UIs, the object that holds all of the components in the canvas, or hold all the components in the UI, is the canvas. You generally do this to create things like overlays and menus. And so essentially you create a base canvas, and within that, the children of the canvas would be different elements such as images, buttons, and text. And so you can see in the pictures there, the left one is the one of the hierarchy. We have a power-up select screen canvas, which contains panel, text, and all the buttons. And you can see how that displays on the right. And more specifically in those objects within the canvas, the panel is actually the colored background. The text is obviously the text that shows the titling select to power up. And then the buttons essentially do things based off of a public function that you create within a script that you attach to each button. And so on click of these buttons, it will run that public function and do whatever you tell it to do. And so next is the Unity Engine Scene Manager. So a scene we've gone through before. It's essentially the different screens or levels in your game, whether it's the main menu, the options menu, or level 1, level 2, etc. And the scene manager or scene management is essentially a imported Unity library, and you use that to create a scene manager class that contains all of these public functions that you can see on the right here. So it's public void, start game, level select, back, and shop screen. And essentially, like I said before with the buttons, you would create a button and attach these public functions to them. So then on click of those, then it would run these, and the scene manager would load the scene that you tell it to within the script.
Okay, so once you've used all these basic tools, you've built your game and you've played with all these different things, different objects, different scenes, and you're coming to a completion point, you're just going to have to create a build, because you have to be able to distribute your game and run it outside of the Unity engine. And in Unity, it's actually very, very easy. Not outside the Unity engine, outside the Unity editor. So in Unity, it's actually very easy. You just go to Edit, File, Build Settings, and you just select the directory in which you want to build your game. You can build your game into plenty of different platforms. Like, for example, here I use my PC to build a Mac OS build of this game, which worked just as well. And basically, when building, you are making it so that you serialize your assets, that no one can go and steal sprites, pull anything, or at least it makes it significantly harder to do so. And it just allows you for a little bit more security after you built your game. And yeah, you're going to just basically build a few different builds as you get farther and farther into your project until you reach a final build. So if you are working alone, it's sometimes, or you're just a beginner and you don't have many resources, something that you might want to turn to is the Unity Asset Store, which is a very, very helpful tool and a very good reason why you should start off with Unity, because Unity probably has the best asset store of all the open source game engines. Basically, it allows you to download anything from sprites, backgrounds, skyboxes, 3D models, materials, anything you can think of, and import it into your game very easily. There's also a Unity Asset Store window within the Unity editor, which actually allows you to pull those things from the asset store that you download and you own to your account. Many of these assets are both free and paid. where the paid assets are, of course, they cost money and they're a bit more expensive, but they're very, very good and very much more detailed with anything that you can do with basic version of Unity. But there's also the free assets like the sprites and the models, which some people can use because not everyone has the capability to either make the models or they don't have the resources and time to spend if they're working on the game alone. So yeah, and also the asset store contains many tutorials which you can use and practice your Unity skills with. So it's very good. I put the link up there. This PowerPoint will be shared later, so I'm sure you can access that link, but it's assetstore.unity.com. Yeah, so that's basically Unity. But if you were a Penn State student, I would like to say that, and you are interested in learning more, you can consider joining our club. We are not a standard club by nature where we have big general body meetings, but instead what we like to do is we like to sort students to small groups. And now our club members aren't only programmers, but we also have artists and game designers and musicians, and they work together to create games within these small project groups. So basically, we work in a system where you learn by experience. And we are accepting anyone with at least a little bit of background, any skill, and it's just as easy as joining our Discord, which, as you can see on the screen, there's both the QR code and the Discord link. If you want to join that, you can go right ahead, and we will try and get back to you as soon as possible. Just follow the instructions in the general README screen and select a role that you want and agree to our terms, to the terms of service, and just you go right ahead and one of our officers will try and contact you. So that's basically it for our PowerPoint. I know this was quite boring, but it will be provided and you guys will be able to reflect back. I know we threw a lot of information at you, but don't worry. I know there's going to be a recording of this lecture, but there will also be the PowerPoint upload later, which you can refer to. But this is basically, now you have an idea of how developing in a game engine works, and especially in Unity. So when you jump in, you're not as lost as you are. But actually, what's going to happen now is we are going to show you a little bit of a demonstration. Jonathan's going to do that. I'm going to stop sharing this PowerPoint, and we can do more. Later, if you still want to access these links, we will post them in the chat if necessary. And you can try and join whatever you'd like if you're comfortable. But I'm now going to stop sharing, and Jonathan's going to share his screen and show you a little bit of a demonstration of actually using Unity.
All right, so I'm just going to go through a quick thing through Unity. You guys are welcome to follow through if you'd like, but what I'm doing is very simple. I'm mainly showing you the different parts of Unity, but I will be doing a simple movement, player movement script as well. So this is what you'd see if you opened up a brand new 3D Unity project. You'd get a main camera right here with a view and a directional light. And top here, you'll see the scene and the game tab, which is essentially what the camera sees. I'm going to drag this to the right so we can see both at the same time. And so I'll just get started here. So first, I'm going to create a 3D object by right-clicking in the hierarchy. And I'm going to make a plane. And I'll move the camera up a little bit so you can see the plane. And there we go. I'll rename it ground just so we know what it is. And first off, you can see on the right side here, once I click on an object in the hierarchy, then it shows up all of its components in the inspector window. It has the plane mesh filter, the mesh renderer, and then the collider, which is very important for what we're doing here. So next, I'm just going to make a 3D object, a sphere, move that up a little bit, and I'll name this player. So now, once again, you can see on the right here, it has its own set of components, a sphere mesh filter, a mesh renderer, its own transform, and a sphere collider. Now, I'm going to start right here by adding a new component, and we're looking for the rigid body, which we talked about before. The rigid body will allow us to add gravity. So now it has use gravity here already checked by default. And both of the items have colliders, which is important. So if I go ahead and just press play here, then the ball will fall due to gravity and it will stop because these two planes are colliding. So I can lift it up again, drop it, and it'll do the same thing. Now, if I turn off gravity, then we can see that obviously it won't drop, but I can turn it on in the inspector window live. It'll drop, and then I could even turn off the sphere collider here and it'll go right through because there's no collision happening. And so next, quickly, I'm just going to go to the asset window, right click, and add a material. I'll name it player because I just want to make the player a different color for better visibility. I'll just make it red and then drag it right onto the player object, and now it's red. If you actually go click on the object, then you can see I added the player material here. Before it said default material. All right, and now next thing I'm going to do is I'm going to click on the player. I'm going to go to its inspector, and I'm going to add a new component, and we're looking for a script, a new script. I'm going to name this script player movement. Once you create that, it's going to show up in your asset window here, and it won't open by default, so you can go ahead and double click on that, and it'll open Visual Studio. And so like we showed before, this is what happens when you open a brand new script. It's public class player movement, and it extends mono behavior. And so it starts with these two void functions by default, which we talked about before. Void start will, upon the first frame, will run this, whatever's in this once. So just to showcase it, because I won't be able to use it in what I'm trying to do, but I'll just show you what it does. I'm going to do a debug.log, which shows a message in the console window of the interface. And all I'm going to say is hello world. So I'm going to save that. Once you go back to Unity, it'll refresh. I'll switch to the console at the bottom here, press play, and it'll say hello world. And I'll turn gravity back on here. Forgot about that. All right, and so we'll go back to the script now. And now if I actually take this and move it to void update, which runs every single frame, save that, let this update, run that. And now it's just printing out hello world every single frame. So we'll go back to Visual Studio here. I'm going to put that back in start. We don't need it, but I'll leave it there for now. And now what I want to do is do basic movement of the sphere itself. And so first I want to start out by recording the starting location of the sphere. And that's just going to be a vector3 variable called position. And a vector3 is basically just an array of 3 numbers, but in this case, we utilize it in a way that, I guess, keeps the x, y, and z coordinates. And then we're going to set that equal to the transform.position. And so we talked about transform before. It mainly tracks the position, rotation, and scale of the object. In this case, we want the position. And when we say transform, it automatically knows that we're talking about the current object that this script is attached to. So if we had reference to a different object, then we would put that object's name .transform. And so next we'll do an if statement, and we want to check their keyboard inputs. So we'll do input.getKey, and getKey will track if the user holds down a key, and we'll do keycode and we'll just do W. And so now that's all set. Now what we want to do is we'll move this in the forward direction. If we go back to Unity, the forward direction is actually going to be the Z axis here. So what I'm going to do is I'm going to do position dot Z plus equals 0.1 F because it has to be a floating point number. Under that if statement, we're going to reassign the transform of the object to the transform variable that we created. Save that, and then let Unity reload itself. And now if we run that, we can see in the game window here, if I press W, then it moves forward. And so to move in all the directions, all we would have to do is copy that 3 more times. To move backwards, we just want to change that to subtract. Move to the right, we just want to change the axis to the X because the Y is actually for height, and leave it as plus. Change this to A, switch it to minus, and then switch it to X. And then we move back to the Unity window, hit play. And now you can see I'm moving right from holding D, left from holding A, backwards for holding S, forward for holding W. And if you hold both, then you can move diagonally. And there you have it. That's a very short and very basic intro to, I guess, navigating the interface here and just doing basic movement within a script.
All right, thank you, Jonathan. And once again, if you want to stop sharing, I'll put up the link again for the Discord for our club. But basically, all we have to say at this point is this is what Unity basically looks like. That's how it builds. You have reference to all these things. Once again, if you're a Penn State student, please, you can go back if you missed it before. You can join us and learn more if you're interested. So now we would be taking any sort of questions. We have a good 10-15 minutes left. So any ideas, questions, concerns you may have, you can please ask us in the Q&A and we will read through them. So thank you very much. And that is all today. It was nice having the opportunity to present here. I want to thank HackPSU for doing an event in this horrible situation that we are in the world. And it is just great to have an opportunity to introduce some more people into the field of game development, which is something that we are very, very passionate for. And just get creating, start learning, play around, can never go wrong. And that's all.